Okay, so the next test, okay, new exercise 4.4. The first test, right along with me, test 4.4A. This will cover, okay, starting with the exercise 4.4, question B1. We'll find this in textbook page 95. Okay, right along with me the portions as well. Let us start it. Before we start this, let us remember the three primary conditions we're going to use, okay, for a quadratic equation. Now you can write it down. If ax squared plus bx plus c equal to 0, which is the general form for a quadratic equation, is given, okay, is the, you can just use that, is the given quadratic, equation, and discriminant. This is called discriminant. We have discussed this slightly even in previous exercise. And discriminant, which is denoted by the letter D usually, is equal to b squared minus 4ac, meaning the discriminant for this quadratic equation is this one. Then we can get three conditions. Then we know, number one, A, if this D equal to b squared minus 4ac, okay, is equal to 0. If D or b squared minus 4ac both are same, is equal to 0, then okay, then it has two real and equal roots. This is the first condition we need to keep in mind. If any given quadratic equation has this condition, discriminant b squared minus 4ac exactly equal to 0, then we can be sure that it has two real roots which are equal. Okay, just write it down, and as we go on we will explain more. Now B, second condition is if D, this one equal to b squared minus 4ac is greater than 0, then it means this equation has two real and distinct roots. Write it down. Two real and distinct roots. Then here, third condition is if this D, which is discriminant b squared minus 4ac, is less than 0, means it come out a negative value, minus 1, minus 2 are all less than 0, then it means this equation has, or its two roots are unreal. You can just write it has two roots, two unreal roots. It has two roots which are not real. Or we can also say the one that is, in short also you can say its two roots are not real, like that also you can write, are not real. You can say it has two roots which are not real, or in short also its two roots are not real, like that. So for real roots are the condition A and B. When it is equal to 0, there's two real roots which are equal. When D is equal to b squared minus 4ac is greater than 0, then it has two real but they are distinct roots, means different, not equal. Distinct means not equal. Okay, Write it down. Okay, then I'm going to write these conditions in short so we can use as we go on in this solving this question. So let us summarize again. You need not write it down if you don't want, but for me I'm just writing to show, okay, because you've already written. I'm writing in short now. If this d equal to b square minus 4ac is equal to 0, it has two real and equal roots. The first condition, keep that in mind. Two real and equal roots. Second condition b, this d if is equal to b square minus 4ac is greater than 0. It has two real and distinct roots. Two real and distinct roots. Second condition that we're going to use. I'm just writing in short so we can refer to these three conditions as we solve, because we're going to need it. So the third is d equal to b squared in case it is minus 4ac is less than 0, then its two roots are not real. So the only condition where we wouldn't get real roots is the third one. The first two will produce, but not real. Which one? It has two roots. Its two roots are not real. Okay, let's start solving. B1 subheading 1. Let me read the question first. Find the nature of the roots of the following quadratic equation. So we have to find the nature, means we have to find the discriminant, this b square minus 4ac. After that, if you find that if the real roots exist, that means if it has condition 1 equal to 0 or greater than 0, then it has real roots. Not real is only the third. So if it is like 1 or 2, then find them, means solve them. Solve. Because if the roots are not real, we cannot solve, right? So here, let us write the given equation. 2x squared minus 3x plus 5 equal to 0. So as we know, we have to find the coefficients of x squared, which is a plus 2. b is the coefficient of x, in front is minus 3, and c is the one, the third term having no x squared and x, which is plus 5. So we have to find the nature of roots, means we have to find this. d equal to b squared minus 4ac. So b here is minus 3, so put that in a bracket and square. 4 into a, bracket itself can imply multiplication, so into, so c is here 5. Solve it carefully. Now minus 3 square is minus 3 into minus 3, so minus into minus plus 6 3s are 9, so this will be plus 9. Minus into plus, because no sign means plus, and minus into plus minus, minus into plus again, minus. 2s are 8, 8 5s are 40. So we know this is just a case of minus 40, bigger absolute value, smaller plus 9 down. You can write those things on the rough. Okay, when it is a combination of minus and plus, we subtract. So 40 here, 10 minus 9 is 1. To make 10 here, we borrowed 1 from here, so 4 goes down to 3. Only 3 left, and bigger minus, bigger absolute value sign is minus, so here also minus. So plus 9 minus 40, in other word, is minus 31. This minus 31, the value of b squared minus 4c, is definitely less than 0. Any negative number is less than 0. On your integer line, 0 is the middle. On the right side are plus 1, plus 2, plus 3, all greater than 0. On the left are smaller than 0, minus 1, minus 2. So minus 31 would be on the left. So it's smaller than 0, right? So here now. So if it's less than 0, then we write here. You can just write, therefore, it has no real roots. The nature of the root is no real roots. Or you can write its two roots are not real. So condition 3c is coming out. Question is saying if it has no real roots, then stop there. Find the nature is no real roots, stop there. If it is real root, you solve. So extra step. But this one not real, so we can stop here after finding the nature. Okay, so wait 1 minute before you write that. You can just write properly once. So here you write once. Since this value here, d is equal to b square minus 4ac. So you write here d, or you can just write singly this also. D is equal to b square minus 4ac. We calculated and found out minus 31 means less than 0. Therefore, it has no real roots. How do we know? Because we know the third condition. Since d equal to b square minus 4c is less than 0, exactly like this, it has no real roots. Okay, let's try the next one. 2. Subheading 2. See, 3x square. Okay, follow me. 3x square. The same question on your textbook, page 95. 4 root 3x plus 4 equal to 0. So as we've done just now, our first job is to find out the coefficients of x squared. A in front plus 3. B is the coefficient of x in front is minus 4 root 3. And C is the third term plus 4. So question is saying find nature of roots. So we have to find this discriminant. So therefore you write d is equal to b square minus 4ac. So b is here, as we can see, minus 4 root 3. Put it in a bracket, square minus 4 into a into c. A, c. I hope you're getting right. Now here minus to the power 2 means minus 2 times, so plus. Then 4 fours are 16. 4 square. Then this square belongs to this also. So root 3 square is root 3 into root 3, we know is 3. Just like root 5 into root 5 means root removed. So root 3 square, 3. 4 square, 16. Minus square means minus into minus, plus. So no minus sign. So you multiply this. That's our answer for minus 4 root 3 whole square. 6 3s are 18. 6 are 18. 3 1s are 3 plus 1 4. You can write those things on your rough. Okay. Then 48 plus 48. Then minus into plus minus. Minus into plus minus. So 4 3s are 12. Minus 12 4s are 48. You can try it. Plus 48 minus 48 is 0. Now, just now, since you write down, since we found out this is equal to 0, so we can write here since just now, you can write the whole thing if you want. D discriminant value b square minus 4ac value is equal to 0 means exactly equal to 0, which is equal to here, this one. D is equal to b square minus 4ac equal to 0. It has two real and equal roots. So you write here it, therefore it has two real and equal roots. Then look into your question again, second sentence. If the real root exists, like this, find them, means we have to solve it. So in this chapter, I think you can solve by any method, but it's better to go by quadratic formula, I think. So using quadratic formula. So you write down quadratic formula. All of us know in the previous chapter we have done. Even in this chapter, I guess, no, in the previous one. Quadratic formula is x equal to, long line, minus b plus minus root over b square minus 4ac divided by 2a. Okay, so once we're through with that, then we can go here. So that gives you equal to, longer line, minus, then b, look up, and you see here b is minus for the formula and b has another minus, so you write minus 4 root 3. Okay, so you can just put here in between these two minus sign bracket, so minus b. Then next plus minus, so write that down, root over minus plus minus root over b square. So b is here. Minus 4 root 3, whole thing bracket is must. Okay. Must include everything minus 4 and root 3 also. B square and minus 4ac. So, okay, I think this is, you can shorten it if you want. Because we have already, this question is saying nature of root, so we would have already found out the value of d. So go and see d, b square minus 4ac. Here is 0. So here, instead of wasting time and calculating again, you can just put the root over. Since this b square minus 4ac is exactly this one, see, solving 0. Put that 0 divided by 2 into a. 2 into a is here 3. So write it down. Then here we're going to get minus and the minus is plus 4 root 3 plus minus root over 0 means 0 divided by 2 3s are 6. Right, 2 3s are 6. So our first answer is 4 root 3 plus 0 by 6, comma. The next 4 root 3, the next minus 0 by 6. So here 4 root 3 by, next step 4 root 3 by 6, because 4 root 3 plus 0 is 4 root 3. 4 root 3 minus 0 is also 4 root 3 by 6. So 2 2s are 4, 2 3s are 6, 2 2, 2 3s are 6. So we're getting here 2 root 3, first answer, by 2 root 3 by 3, comma, 2 root 3 by 3. So the roots are equal or same root. That's what is meant by here. It has 2 real roots. Every quadratic equation has 2 roots, but they're equal, see, exactly equal. That's what is meant by it has 2 real and equal means similar, identical roots. Okay, first one. 2 root 3 by 3. I think we made some mistake here. Just hold on once. So here, minus here, b. So here minus b is, let me check once, 3x square minus 4 root 3x plus 4. That's correct. 3 minus 4 root 3. That's correct. Then b square, okay, by quadratic formula, minus b plus minus root over b square minus 4c is 0. Minus b here, minus and minus, 4 root 3. 2a, so 2 into a, 2 3s are 6. Okay, let me check the book answer at the back. 4.4. 4.4 b 2 by root 3. You must be getting 2 by root 3. 2 3s are 6. 2 2s are 4, 2 3s are 6. 2 by root 3. Okay, so here 4 root 3 by 6. 2, oh yes, the book answer is this is the same as book answer. You can stop here like this, but the book answer is given 2 by root 3 is the same. They are doing like this. So here, if you want to get it in the form of book answer, then here continue, then not wrong. Okay, that you can stop here if you want. I don't know why they're going extra step and doing like that again, but if you want the book answer, continue. So as we continue here, just continue from here, equal to 2 root 3 by 3, same thing. And to remove this root, just multiply root 3 up and down. Then 2 root 3 by 3 multiply by root 3 up and down. That way it is multiplying by 1. See, root 3 by root 3 is 1. Then, but don't cancel. Root 3 into root 3 is 3. This is 2, then root 3 into root 3 is 3. Then here, 3 root 3, 3 into root 3. 3 root 3, then these 2 cancel. Then, comma, 2 into root 3 into root 3 is 3 by 3 root 3. These 2 you cancel, then your final answer is going to be like book answer, 2 by root 3, comma, 2 by root 3. So we can write like that. Even though I prefer to end it here, but the book answer is giving in this form. Okay, so one more question before we end this test part. It's correct and we just need to continue. Now b 1 subheading 3, the last question. Here, the given equation is 2x square minus 6x plus 3 equal to 0. So here we have a value equal to 2, b value equal to minus 6, c value is this one, 3. So write it as such. Then we have to find this d value, which is equal to b square minus 4ac is equal to b is minus 6, the whole thing square minus 4 into a into c, a into c. And minus square is plus, so 6 6 are plus 36. Minus into plus, minus. Minus into plus, minus. 4 2s are 8. 8 3s are 24. 4 2s are 8. 8 3s are 24. So big group one is no sign is plus 36. Smaller one we'll put it down. Plus minus means we subtract. So these things we can write it. Let's check the book answer once. Yes, it's coming in the form of 3 plus root 3 by 3 minus root 3. So here 6 minus 4 is 2, 3 minus 2 is 1. Then bigger one plus, so here also plus. So you're going to get here plus 12. In other words, plus 36 minus 24 is plus 12, which is plus 12 is definitely greater than 0. This one greater than 0. So you can write one more step to make it clear. Since the value of d is equal to b square minus 4ac, this one 12 has definitely greater than 0. D equal to b square minus 4ac greater than 0. So it has two real and distinct roots. We write that. Since it's same d square, d is equal to b square minus 4ac greater than 0, it will write this. So therefore it has two real and distinct. The word distinct means unequal. Distinct roots. So we'll write that down. So if they have real roots, then we can solve by quadratic formula. So using quadratic formula, let's go about this slowly. X equal to minus b plus minus root over b square minus 4ac divided by 2a. Write it down. And let's continue. As we continue, then we're going to get here equal to long line minus b. So b is here, we found out, minus 6. So between these two minus, put bracket. Minus this one here. And then b has another minus of its own, minus 6. So this is b inside the bracket, minus in front for the formula, minus for the formula, then plus minus root over. Then we can just write b square minus 4ac here. Same as this is equal to 12 we got. So you write here 12 divided by 2 into a. A is 2. Then here minus and minus, plus 6 plus minus 12. You can prime factorize it as 2 6s are 12, 2 3s are 6. So here 2 into 2 into 3. You can write like that. Use prime numbers to factorize it. Divided by 2 2s are 4. So we get here 6 plus minus. Then double 2 will come out of the root. That's why we're doing this. Remove, and 3 has no pair, so it will remain inside. Divided by 4. Okay, so here book answer is 3 plus root 3. So we can do that. As you can see here, common factor is 3 is going 3 2s are 6. No, not common factor, 3 2. 2 3s are 6 and 2 here outside. So 2 3s are 6 and plus minus, as you can see, 2 is outside. So here root 3 divided by 4. That way we can easily cancel out this one. 2 1s are 2, 2 2s are 4. So we are left with first one, 3 plus root 3 by 2. 3 plus, then comma, 3 minus for the other one, the 2 roots by 2. These are the 2 roots and they are not same. 3 plus root 3 by 2, 3 minus root 3 by 2. Different or unequal, that's the meaning of distinct roots here. Two real and distinct means opposite to equal, unequal, or different. So that completes the part for 4.4a. Okay, I hope you got it.